Hello. So in this video, what I thought I would do is an overall taxonomy of threats. So we'll do a threat taxonomy in this video. And the idea is to kind of categorize threats along a number of interesting dimensions. So I suspect that this video, I'll actually probably need to break it up into a few different parts. So maybe think of this as part one. Um, Part one. I'm not sure how many parts it'll take, probably about 3 or so parts. And in this first part, maybe I'll do a bit of an overview and talk specifically about one dimension along which threats can be analyzed. And that first dimension is kind of looking at propagation of threats. And so we'll talk about propagation of threats in this video. And so let me actually give a bit of background first. So if you look at the way the industry has evolved in general, the original premise of the antivirus industry, or even the anti-malware industry as a whole, was to cover what were thought of as kind of the original class of viruses, and these were actually called computer viruses, for that matter. And nowadays we have many different kinds of threats, but the original purpose of the industry was to deal with the computer virus. And computer viruses were, are traditionally thought of as what we call file infectors, and I'll talk about what that means in a moment. Okay. And in general, the industry has kind of had to deal with now many more threats aside from traditional viruses. And if you've seen any of the earlier videos I've done on the history of computer viruses, really over the last 2.5 decades, the industry has had to kind of address the original need, which is to remediate the original viruses, these file infectors. But today, there are many, many more kinds of threats that kind of fall under the aegis, if you will, of malicious software or malware. And so today we're not just dealing with virus, but we're dealing with malware as a whole. Okay, and malware represents really all classes of malicious software, of which computer viruses might be one example. So the computer viruses are one offshoot. Now what's happened is that, for better or worse, people have conflated the terms computer virus and malware. The reality is that computer viruses represent one example of malware, but typically people think of, when they talk about malware, they often use the term computer virus, and when they talk about computer viruses, they may use the term malware. So these terms have become conflated. And so even though the industry as a whole has developed anti-malware technologies for dealing with all sorts of different types of malware, people often call them antivirus vendors, even though they are dealing with more things than just computer viruses. So for better or worse, these notions of malware and computer viruses have become conflated. And I'll try my best not to confuse that matter anymore, but just something to keep in mind. When you hear about people who are computer antivirus vendors, it's very likely that they're doing more than just dealing with traditional computer viruses. They may also be dealing with other types of malware as well. So if I had to define or really think about how to taxonomize threats in general, I would say there are kind of three basic dimensions that you have to consider. So what are those three dimensions? The first dimension is really what the threat does. So it's three dimensions, and the first dimension is really, I would say maybe actually how the threat propagates. So we'll talk about that in this video. So propagation is the first dimension. The second dimension is, in my mind, what harm the threat does. So how is it harmful? So what's the harm done by the threat? And the third dimension to consider when you want to taxonomize threats is resiliency. How does the threat try to stay on the system? And I use the term dimension because you may have a threat that has certain types of propagation mechanisms, that does certain kinds of harm, and uses specific techniques for staying resilient. And as I mentioned, computer viruses are one type of threat, and they're focusing more on how they propagate. And in this video, I'll focus specifically on propagation of threats, just because I think it'll be too much to try to talk about all three dimensions in one shot. So traditional viruses are what we call file infectors. We also typically call them parasitic, and this is a term that's in biology, and really a parasitic threat, by that we mean that it needs some type of a host file on which to kind of reside. It cannot stand on its own. And so when you look at a typical computer virus, let's say you have a file on your computer system, on your file system. Maybe you have a legitimate file. Let's say this is, I don't know, some program that you have running on your system. It's a legitimate software program. Maybe it's a word processing program or a spreadsheet or something. And you might have some program file that exists in your system. And traditional computer viruses would basically infect an otherwise legitimate file. They may actually put their code somewhere in that file, and this is where their code resides. So they're effectively modifying the file to do that. And then when you execute the file, when you run the file, at some point it gets that code segment and starts executing that code. Okay, so really these viruses are, and that's why they're called parasitic, they're parasites in that they need some type of a host on which to be located. And then the way they would spread is maybe if you had a new file in the system that you put in, then the virus as part of its code payload would maybe replicate itself onto the new file. And then similarly, let's say you down the line had a, I don't know, a USB stick or a floppy disk, and that's maybe back in the day you had a floppy disk. So let's say you had this kind of floppy disk, which has a, I know people don't use floppy disks very much anymore, but imagine you had a floppy disk, and there were files in the floppy disk, then the virus might try to infect the files that are on that floppy disk, and then when that floppy disk is moved from computer to computer, future files would get infected with that particular threat. Okay, so moving on, the next example of a threat we call worms, and worms are a bit different from viruses in that they're not parasitic, so they're not parasitic at all. They're standalone, so they're not parasitic, and they can kind of stand on their own. And so these are actually entire programs. So maybe a worm would be a full program, and the entire program is just malicious. And then the worm tries to spread from computer to computer, and in the process of spreading, it actually copies the whole file over. Okay, and some of the original worms were things like mass mailing worms that essentially spread over email. There are worms that have been spreading over IM. Some of the most damaging worms actually spread using network vulnerability. So they try to find a network vulnerability and then spread over the network by exploiting that vulnerability. Okay, but the big difference between a virus and a worm is that viruses are not standalone applications. They need to have a host of some sort, whereas worms are standalone. So let me kind of emphasize that term of standalone, because that's really the key distinguishing factor between a virus and a worm. Okay. Now the third class of threats that that people talk about are exploits. So let me talk about Trojans first. So a Trojan, you hear this term quite often. Trojans are basically standalone pieces of software as well, but they are non-replicating, so they don't replicate. Okay, so they're non-replicating. So they're a bit different from worms, because worms actually replicate, but Trojans are also standalone. So they're similar in that regard to worms, in that they're standalone pieces of software, and they can kind of reside on their own. And the idea behind a Trojan is that you might have a particular application, and the idea is the entire, again, just like in the case of a worm, the entire application is bad. It's bad.exe. But the Trojan has to maybe rely on some other propagation mechanism. For example, maybe social engineering, which is a common way that these things are spread, and other mechanisms like that. And maybe I'll talk a bit about, if I have some time at the end of the video, talk a bit about how these threats propagate in a more broad sense. Now, the other way that a Trojan can get onto a system, or really any threat can get onto a system, and how it might propagate, and this is the last category I'll talk about, is exploits. So, exploits. And how do exploits work? Well, exploits basically are designed around taking advantage of a technical vulnerability on the system. So, for example, maybe there's a flaw in the underlying platform, and the exploit code can find that flaw, exploit it, and then get onto the system that way. And not only can the underlying, maybe you might have a computer system of some sort, and not only can the computer system, maybe the entire system is somewhat vulnerable, but maybe even more fundamentally, you may have applications that reside on that system that are, let's say, there's a vulnerable system. You can maybe get directly into the operating system itself, but there may be applications that also run. So maybe some applications that are like a PDF reader, and that's a common way to find vulnerabilities. Maybe a PDF reader is vulnerable, and the exploit code can take advantage of a vulnerability in PDF. Okay, so that's another possibility as well. One of the more common, ways of exploiting something is a web browser. The web browser is an application that runs on the system, and it's entirely possible the web browser's got some type of vulnerability, And if it's got a vulnerability, then you may be able to write exploit code that takes advantage of that vulnerability in the web browser, and as a result gets onto the system in that fashion. And ultimately, though, exploits, they're a way to get onto the system, they're a way to propagate, but it's important to keep in mind that exploits, ultimately what they're trying to do is not just exploit the system for its own sake, but usually exploit it to get some other damaging piece of software in the system. Like maybe it'll exploit the system and then go ahead and put a Trojan on the system, or maybe it'll put a worm on the system, etc. What's interesting is nowadays you don't see very many traditional computer viruses. These are kind of more old school, if you will, or maybe for lack of a better term. You don't see very many traditional computer viruses because worms and Trojans and exploits are now kind of the norm in terms of what you see. So one thing that I haven't discussed so far, maybe I'll spend a couple of minutes discussing, is the techniques for achieving propagation. We talked about kind of how threats propagate, but what are the actual propagation channels? So what kinds of channels can these things use? So one of the most common channels include things like email. And email for the longest time was probably the most common channel by which threats propagate. And so you might get an email that contains, let's say, a hyperlink, or maybe the email contains an attachment that contains an attachment with malicious software in it, and if you execute that attachment, you'll get infected. And nowadays, actually, we don't see as much raw email spread just because mail gateways are becoming better about blocking executable content. You've got better and better spam filters, and so on and so forth. But what we might see is an email containing a hyperlink as opposed to just containing a direct attachment. And that hyperlink might point to malicious content. The other way in which these things can traverse or can propagate is via the web, so internet and web in general. We are seeing a lot more activity in the form of web browser vulnerabilities. And in fact, maybe a lot of websites are laced with malicious code, and that could be because the website itself was exploited. And so typically what happens in this case is you might have a website, and somewhere on that web page there's what's called an iframe. And an iframe is basically a piece of HTML code, and you might actually, it turns out you can actually put iframes that are more or less invisible, that the user can't actually see, but that there's actually code underneath. And an iframe might contain exploit code, which in turn can be used to deliver a malicious payload to a particular web browser by taking advantage of a web browser vulnerability, by exploiting a web browser vulnerability. And so your browser will effectively be used as a conduit by which malicious software can get onto your system. Okay? And now the thing is that I do want to mention that even though worms and viruses and so on and so forth, these things can also have exploit code embedded in them. So these terms, when I talk about a virus or a worm or a Trojan, etc., even though these have different characteristics at a high level, these terms are not mutually exclusive. And I do want to mention that because you often do see blended threats. The last thing I do want to mention in terms of a channel, which I think is a very important notion to consider, is social engineering. And so a lot of threats do spread by social engineering, and by that I mean they basically just trick the user into getting infected. And so it's actually, I think social engineering is the dominant technique that's in use, though at the same time you have to balance that with the idea that even though there are fewer threats that might contain exploit code compared to social engineering threats, a single exploit threat or a single threat that uses exploit code can potentially do a lot more harm and become widespread much more quickly than something that uses social engineering, even though social engineering is the most popular in terms of raw numbers way of propagating threats. So I've actually covered quite a lot of ground in this video, and I think what I'll do is stop right here, and I look forward to seeing you in future videos where I'll break down this taxonomy in a bit more detail.